Kids! I today am going to talk a little bit about energy diagrams and photon emission and absorption and that fun stuff. But let's say I have some weird element that has this is the energy diagram, where this is negative 12, negative 7, negative 5, negative 3, negative zero point 0.5. EVs. So let's talk about a couple things here. The negative 12 is considered the ionization energy. Why is that? Because if I had an electron hanging out down here and this electron went to n equals infinity, which means it leaves, it would take at least 12 EVs of energy to cause that electron to leave the atom. Now, if it absorbed more than 12 EV, now if it absorbed just 12, it would just barely leave the atom. If it absorbed 15, then there would be 3, or at least potentially 3 EV left over. Couple other things just to note with this. These are negative because they're holding the electron to the atom. So if I want to add energy to it, so in order, like for example, with what I just talked about, if I add 12 EV photon to it, well then 12 plus negative, like that's how much you have to overcome, well then you would end up with no energy left over, which is why the electron just leaves, but it doesn't have any kinetic energy. Couple other things that you'll notice that the gap here is the biggest, and the gaps get smaller as you move up. That should make sense. Why is that? Because, oh, by the way, this would be 0 EV. The reason that is because, you know, if you think about an atom, here the electron is closest to the atom, so by the electrostatic force, it's going to really want to be attracted. So it takes a lot of energy to jump this gap, and then less energy to jump to the next one, and so on, which is why it's spaced that away. And then the other things to keep in mind that this electron could only absorb anything where you're going from, or this atom could only absorb the difference in energy. For example, you could absorb if you went up to here, that would be you're absorbing an 11.5 EV photon. You could absorb a 9 EV photon. You could absorb a negative, or a 7, sorry, not a negative 7, but you would absorb a 7 EV photon, and then you could absorb a 5 EV photon, but you could also absorb 6.5, 4, 2, you could also absorb 4.5, 2, I guess we already did 2, that's kind of, it just worked out that way, and then you could also absorb 2.5. That's not right. Let me change that. Sorry. We're going to make this guy a 1.5 EV. Hopefully you guys understand why, because otherwise my gaps wouldn't be getting smaller. So there you go. So sorry about that. Let's see what else. So that would be all the absorption ones, and you could also absorb a 12 EV photon. If you wanted to go the other way with it, so like that would be absorbing. If you're going to be emitting photons, okay, then that means that the electron is starting in a higher energy level, and it's going to drop down to a lower energy level. So, for example, you could emit, if you're going down, you're going to emit. You could emit, sorry, my numbers from before are going to be goofy, but they're going to be different because I screwed up before, but this one would be a 10.5 EV photon. This one would be a 9 EV photon, a 7 EV photon, a 5 EV photon, a 5.5, let's see, that would be a 3.5, a 1.5, what else could you emit? You could emit let's see, you could go from there down, it could go here, I've already done that one. Did I miss other ones? Let's see. I missed this one. Okay. And I missed this one. So this one would be a 4 EV photon, and this one would be a 2 EV photon. So let's say the question asked, now, one more thing. Let me just mention, and then we'll do a sample question. It will only absorb those. So, for example, this is 5. If a 6 eV photon hit this, well, 6 is not the difference between any of these. Well, that photon would not interact with this atom at all. It would just pass right through it. So yeah, but let's say you wanted to know, I don't know, for the photon going from n equals 4 to 2, what the wavelength would be. So to do that, you would have to say, well, my change in energy is 4 eV, and then you would say, well, that equals HF. Make sure you're using the H. That would be 4.14 times 10 to the minus 15th for your Planck's constant. You could solve for F, and then you could use this equation to solve for the wavelength, where that would be the speed of light. Okay, and that's pretty much it. So, hope that helps. Bye, kids!